understood two approaches of doing multi-class classification, right? Two approaches of doing multi-class classification. Can somebody tell me what those two approaches?
One versus one versus all.
Yes, one versus one and one versus all. We are going to look into the third approach today. Okay. In one versus one versus all, we are doing binary class classification only, right? Many times we are doing it. We are taking the data set and transform the data set in a way that supports one class. Each of the data sets supports one class. And then we are doing multiple models and passing the record and trying to look at the probabilities and predict, right? One versus all or one versus one. In one versus one, we are building more models with less data. In one versus all, we are building less models with more data. Okay. Basically, the idea is same: binary class classification and multi-class classification. When you use one versus one and one versus all, the idea is same. Today, we are going to look into a concept called as softmax regression classifier. This is a multi-class classification approach without using binary class classification. Okay, this is a multi-class classification approach without using binary class classification. This softmax regression classifier is very important in deep learning. Logistic regression and softmax regression classifier are the ones we are going to use as the target nodes in deep learning. What is target node? The output node and all we'll understand there. But softmax regression classifier is very important for deep learning. You remember that and you understand this concept, and we are going to use it there again. Okay. Generalized logistic regression model to support multi-class classification without combining multiple binary classifiers. Without combining multiple binary classifiers is known as softmax regression classifier. So we generalized the logistic regression process. Generalization means magnifying, right? We use more data, more whatever, right? Softmax regression classifier we call it, or multiple logistic regression. Okay, we call it as softmax regression classifier or multiple logistic regression. So in this, if you have 10 classes, right, we'll take 10 sets of thetas. In linear regression or logistic regression, what are we doing? We are taking one set of thetas, theta 0 to theta n. Okay, but if you see here, theta 0 1, theta 1 1, theta 2 1, theta n minus 1 1, theta n 1. A theta vector for the class 1 are 0, right? In our what you call it as the digit recognizer data set, this theta set is for 0 class. This theta set is for one class. Like that, there are 10 classes. You will be taking 10 theta sets. When I say 10 theta sets, 10 random theta sets. Okay, and 10 random theta sets. How many in our digit recognizer data set? What is the n? What is the n?
Number of rows.
Number of columns.
Number
of columns. Theta is going to multiply each column, right? Each feature, right? So there are 784 features. So 784 thetas for theta 0, 784 thetas for theta 1, sorry, class 1, 784 thetas for class 2, 784 thetas for, like that it's going to choose 10 by 784. Sorry, 784 by 10, 784 by 10. If you consider the whole thing as one matrix, right, it's going to be 784 by 10, 784 rows and 10 columns. This far we are clear? Are we clear? Okay. Now we will calculate logit. The algorithm will calculate logit. See this theta transpose x. I said K here, right? Because if you see capital theta 1, capital theta 2, capital theta K minus 1, capital theta K, right? For each class, one theta set. I am denoting that theta set with capital whatever, right? And theta transpose X, what is this? What is theta transpose X? Theta K transpose X or theta transpose X?
So one row transpose.
No. What is the outcome of theta transpose X? Theta K, right? If you put K is equal to 1, right? K is equal to 1. Place K is equal to 1. This transpose X. What is X? What is X?
One input row.
Total data, not one input row,
Okay.
right? Capital X it is, right? Total data, right? If you put total data and transpose this and multiply, what you get? Predictions of each day, each record, right? Not predictions, the linear combinations of each record, right? Linear combination of each record. Do you remember?
Yes, yes.
Shall I explain? Shall I show you?
Yeah, please show that.
Yeah. This theta transpose X will not leave you. The whole AI career, theta transpose X will not leave you. So you should remember that. Okay. So let me take a whiteboard. So I'm going to take out the case and all that and then explain you, right? The same old concept what I explained. So you have set of thetas, right? Theta 0, theta 1, theta 2 and so on, theta n. It's a row vector. And then what you did X, you considered each row as a column vector. Each row as a column vector, right? So first row is going to be the x0, 1, x1, 1. That superscript brackets is the row. Okay, it denotes row. x2, 1.
Sir, you are writing somewhere else, sir. We are not able to see anything. At least I'm not able to see. Only screen I'm seeing.
Oh, really? Entire
No, sir.
screen?
We are able to.
You are able to see now?
Yeah, I can also see.
Yeah, now it is visible. Now.
Oh, good. So x3, 1 and so on, xn 1, right? And x0, 2, second row. I'm putting row as a column, then only theta transpose X will work. If I don't put row as a column, right, X theta will work. Okay. So theta 1, 2, sorry, x2, 2, x3, 2, and so on, xn2, right, and so on, right? xm 1, sorry, x0 m, right? mth row I am representing as a column vector, right? x1 m, x2 m, x3 m, and so on, xn m. Okay. So now, right, if you do theta transpose X, you will get linear combination of all the input values. These are all input values, right? So what is theta transpose? It is going to be, this is n plus 1 by 1, right? This is n plus 1 by m, right? M number of column vectors, right? Or row vectors, right? So now if you do theta transpose, right, it's going to become like this: theta 0, theta 1, theta 2 and so on, theta n. This is 1 by n plus 1, right? X is same, right? Whatever we have x here, That's going to come here, n plus 1 by m. Now when you multiply, right, this whole row multiplies this whole column, right? Then what you will get? Theta 0 x0 1 plus theta 1 x1 1 plus theta 2 x2 1 and so on, theta n x n 1, right? This is linear combination of first row, right? Linear combination of first row with these theta set, right? With the whatever random theta set, or maybe in a thousandth iteration derived theta, it doesn't matter, whatever theta, right? Or after finishing all the iterations, these may be the best thetas, right? Using best thetas you are putting, or the first thetas, or in a particular iteration thetas, it doesn't matter. And again the same row will multiply the second column. Then what happens? Theta 0 x0 2 plus theta 1 x1 2 plus theta 2 x2 2 plus and so on plus theta n xn 2 and so on, right? Theta 0 x0 m plus theta 1 x1 m plus theta 2 x2 m and so on, right? Theta n x n m. What are these? First row's linear combination, second row's linear combination, nth row's linear combination. A vector you get as an output. Okay, m rows and one column vector you get, or one row m, 1 by m. Actually, this is going to be a 1 by m, right? It's not a, I don't have space there, and I spell it wrong, right? 1 by m, right? 1 by m is the outcome, right? One row, m number of columns. It's a row vector you get. Okay, got it? Got it? Questions?
It's a column matrix, right?
Row matrix only. One row and m number of columns, right? 1 by n plus 1 and n plus 1 by m, right?
Yeah, if it is one row and m columns, then it's a column matrix.
One row and m columns, right? Like this. Row matrix, right? Row matrix, right?
Okay. You don't have the space, that's why you wrote below.
I actually I actually said it wrong and wrote it wrong, but I corrected it by looking at the dimensions, right? I corrected my statement.
Okay.
The same thing is present, whatever I am showing here is already present in gradient descent slide. Right? See this? Rows converted and then theta transpose x I did, and then I took the whole data and then did theta transpose x. This is what it is, right? The same thing I showed there. Okay.
Yes, that's correct.
Right? So you have it. I think I'm just trying to point it to the slide which is neatly presented. Okay. So these are all going to be predictions if it is a linear regression. Okay. If it's a linear regression, right? There are all predictions. If it is a logistic regression, right? It is the value we substitute into the hypothesis function. 1 by 1 plus e power minus g1, 1 by 1 plus e power minus g2, 1 by 1 plus e power minus gm, like that. Okay. Good, right? Sir, Girigar.
Yeah, it's fine.
Right? Theta transpose x, theta k transpose x is you take the input data and multiply with this first set. Okay, that is first linear combination of data with respect to first theta set, and the second theta set, right? Again, you take the x and multiply with the second theta set. That is a linear combination with respect to second theta set. Like that, k number of classes are there in our handwritten digit, right? You will have 10 logits. You will get 10 logits. Okay. So for each row, there will be a linear combination with respect to kth class. So what are we doing here? We took, the algorithm will be taking random thetas and then multiplying, calculating the logits and then calculating probability using this formula. What is the probability? Exponential of skx, right? If you take probability of 0 class, it's going to be e power logit of x with respect to theta 0. Okay, divided by all the other, all the other and including this, all the exponentials. Okay, exponentials of all the logits. Like that, you calculate all the probabilities for k number of classes. For each record, you calculate probabilities, and then, right, whichever probability is high, the record is going to be predicted as that particular class. If P2 is high, right, then we say the record belongs to second class, or first, number 1. Okay. If P5 is high, then we say the record belongs to number 6, handwritten digits, right? Number 6, number 6. If it is 6, it is 5. Okay, one number less. Okay, like that we'll predict. Once after predicting, right, it will look into the cost function. There is a cost function called as cross entropy, and it will try to reduce the cost function. Okay, we'll look into the cost function in a moment, but using random set of thetas for each class, it is going to calculate logits, and using logits, it's going to calculate probabilities. Using the probabilities, it will make prediction. Once after prediction is made, it is going to look into the cost and adjust the thetas in such a way that the cost will reduce. This is Softmax regression classifier. Any questions?
Yes, sir. So the exponent of that sk of x.
Yes.
What is that value of that function?
What is the value of?
What is the value of exponent of sk of x?
That is this one, right? We actually calculated for each row, this value we calculated, right?
Right.
For each row, right? Let me open the slide. It is going to be neat. For each row, we calculated linear combination, right? When you say e power of a matrix, right? E power of a numpy array, this is going to be e power of this value, e power of this value, e power of this value, like that. Okay. For the first row, you take this value, right? And then divided by all the different sets, theta sets combinations. For every theta set, there will be a. Let me try to come back and explain. So there is one theta set here, right? For this theta set, there is going to be one value for the first row. Do you agree? This is first rows, right?
Yes,
Linear combination. For the second theta set also, there will be another value calculated using first row. Do you agree?
Not so clear, sir.
Okay. So see this. This is one set, right?
Yeah, that is clear.
Right. Let me try to take numbers and explain. Maybe that would be more clear. So let me take simple example, right? I have a data set with x1, x2, and y. Okay, only two input values and one output value, right? When I have x1, x2 only, I'll have theta 0, theta 1, theta 2, right? X0 is going to be 1. It is called as bias term. For every row, it's going to be 1, right? This till here we are good, right? So now, right? Suppose that in the target variable we have 3 classes, right? 1, 2, 3, or maybe I'll put some other numbers, maybe 6, 7, 8 are the different classes. Distinct classes in Y are 6, 7, 8. Okay, distinct classes in Y are 6, 7, and 8. Okay, now we need to, if softmax regression classifier is working, what it will do is it will take theta 6, theta 7, and theta 8. 3 sets. Okay, 3 sets of thetas. So theta 0, theta 1, theta 2. Okay, so for For theta 6, I chose a random set, right? Like maybe 10 is theta 0, 5 is theta 1, and maybe 8 is, maybe 11 is the theta 2. Okay. And for theta 7, right, I chose 1 as theta 1, right? Theta 0, and maybe 9 as theta 1, and then maybe 13 as the theta 2. And for this also, I have chosen 2 as the theta 0, and maybe 14 as theta 1, and 15 as theta 2. Right? These are the these kinds of random theta sets. Now I need to calculate logit. Right? If I have to calculate logit, right, what I will do? I will calculate theta transpose x. Right? In x also I will take values here. Maybe 5, 8, 9, 7, 8, 10, something like that. Okay. Now what it will do? What will we do? We take this matrix and multiply with that. Let me take another color. We take that matrix and multiply with that matrix, right? Sorry. We take this matrix, this vector, and multiply with this matrix. Okay. You will get some value, right? Theta 6 transpose x, you will get some value, right? Theta 7 transpose x, you will get other value, right? Theta 8 transpose x, you will get one more value. You get only one value, right? For each row, you will get one value, right? Take the first row, and try to do that, you will get one value, right? What is the value? This, this transpose is going to be 10, 5, 11, right? It's going to multiply this row, right? So when you do theta transpose x, right, this, I think I denoted wrong. So this we need to take it as a column matrix. It's going to be confusing. So when you do theta 6x, right, you're going to get for one record, right? I'll take one x1. Okay, x1. For the first record, you will get only one value. Do you agree? When you do theta transpose x, agree?
Yes.
There will be some value, right? So suppose that you take 55 as this value, 65 as this value, maybe 45 as this value. Okay. Now you need to calculate the probabilities using softmax regression classifier, right? P6 is equal to e power 55 divided by e power 55 plus e power 65 plus e power 45. P7 is equal to e power 65 divided by e power 55 plus e power 65 plus e power 45. P8 is equal to for this record only, right? When you do vectorized implementation, right, you can actually do it easily for all rows, right? So P8 is equal to e power 45 divided by e power 55 plus e power 65 plus e power 45. This is how you calculate probabilities. Why you are actually normalizing it? This is called as normalization in the denominator. When you sum up these three, right, P6, P7, P8, you will get 1. Got it?
Yes, sir.
Right? That's what we are doing here. Right? First classes exponential divided by sum of all the classes logit exponential. Second classes exponential logit divided by all other classes exponential logits. Like that, k number of classes are there, k number of probabilities you get. Got it?
So if the sum is 1, then why we need to divide it? It doesn't matter, right?
So sum is going to be 1 only when you divide it. Rather, it's not going to be 1. If you just calculate e power 45 plus e power 55 plus e power 65, it's going to be a number, big number. E is going to 2.3 something, 2.37 some value, 2.374 or something. Right?
But the probability sum will be 1, no, but not the exponentials of those values. So we have three probabilities here, right?
Yeah, we are calling it probability because we are normalizing it and the value is going to be between 0 and 1. When you normalize it, right, then only it comes, between 0 and 1, right? These values will come under between 0 and 1.
Yeah, that's actually correct. But the sum of probabilities will be 1, but not the exponentials of 45, 55, and 65.
Yes, yes, sir. Sum of probability is only 1. Sum of probability is only 1.
Yeah, please go ahead.
Girigaru, is it clear now?
Yes, sir.
So that is, this is another technique actually. It's all mathematical tricks basically. If you look at it, it's all mathematical trick trying to produce a value that actually favors that particular class. Okay. So if the probability of that particular class is high, we say the record belongs to that class and then calculate the cost. Again, based on cost function only, it is going to adjust thetas. By looking at the cost function, it will adjust the thetas. Now, for adjusting thetas here in softmax regression classifier, there are algorithms called as BFGS, LBFGS. I never looked into those algorithms, and they are not used in anywhere else. Only in the softmax regression classifier it is used. They are complex in nature, I heard, right? If you want, right, you can spend time, but nobody is going to ask about it, or you will never be using it in anywhere else. Okay. So how exactly the theta is calculated, next theta set is calculated, we are not bothered about it. Got it? In gradient descent, we actually tried to understand how the next theta is calculated because that is the basis for deep learning. Whole deep learning uses that algorithm. But this LBFGS algorithm, BFGS algorithm, those algorithms are not used by any other place. Only softmax regression classifier uses. Okay, by looking at the cost function, it will calculate next set of thetas. Again, calculates the probabilities. Again, predicts, and then looks at the cost. Again, adjusts it. So this is how it actually works. So softmax regression classifier works like this. So this cost called as a cross entropy. This function is used. This cross entropy function is again used in tree-based algorithms. Okay, basically there is a concept called as impurity. Okay, uncertainty known as impurity. Okay, if you have a bag of balls like this, right? Bag of coins, right? There are 4 blue coins, there are 4 red coins, there are 4 orange coins, and there are 4 green coins. Okay, and there is a bag with all blue coins. Where you will have uncertainty more? If you are trying to pick one coin out of the bag, there are 2 bags. One bag with 4 different colored coins, 4 coins each. Another bag with only blue coins, all blue coins. In which bag you will have less uncertainty? When you are trying to pick a coin.
The same color coins. There is no uncertainty.
Yeah, single color, there is no uncertainty. It is clear. When you pick a coin, right, you will always get blue coin, right? Right? If impurity, that is called as impurity. If you have more combinations in the data, right, you call that as impurity. So you can measure how much impurity is there in a given experiment or in a given data set. Okay, to measure that impurity, right, you use cross entropy as a formula. Okay, entropy explains uncertainty or the impurity. If you get a bigger number, there is more impurity. If you get small number, the impurity is less. I have taken an example like this: 4 red coins, 4 blue coins, 4 green coins, 4 orange coins. If you try to pick a coin from the bag, right, there is a chance that if you want to, if you pick a coin, right, probability of getting blue coin is 1 by 4 or 4 by 16. Total coins are 16, right? Out of which 4 are in favor, right? Blue coin, 4 are in favor, right? Probability I am talking about. Out of all events, how many are favorable? Is the probability. It is ratio. Probability is nothing but ratio. In this 16 coins are there, 4 are blue, right? If you try to pick a coin, what is the probability of getting blue coin is 4. Out of 16, there are 4 chances. Okay. Again for orange is also same, 4 by 16. Right? Red is also same, green is also same. 4 by 16 is 1 by 4. When you try to substitute that into cross entropy, you got a value 2. Okay. Impurity is more, we got 2. And in this second experiment, right, I have got 2 red coins, 2 orange coins, but 8 blue coins, 4 green coins. What is the probability of getting blue coins from the second bag? What is the probability of getting blue coin from the second bag?
8 by 16.
8 by 16, half, 50% chance is there, right? So uncertainty reduced, right? Mostly you get a blue coin. That's like, probability, right? 50% means we have 50% chance of getting other also, right? Like that, when I used the cross entropy formula and calculated probability, I got less impurity. Because of less uncertainty, I got less score. So the cross entropy is more, error is more. The cross entropy is less, error is less. Okay. So in this also, right, when you try to substitute the probability values into this formula, this cross entropy value should be less. So algorithm will try to adjust theta in such a way that the cost reduces, the cross entropy value reduces. Got it? Got it? Any questions? Got it, right? Should I move on? Right? No, yes. Okay. So let me show you. Let me show you one thing here. So let me take a screenshot.
The cross entropy formula is only y log p.
Y log pi. Right? This is, let
Yeah.
me explain. Let me explain. We have seen this before, right? So for the logistic regression, what is the cost function? Minus y log h of x. I can say p, right? P1 minus 1 minus y log P0, I can say, because it is 1 minus P1, right? H of x is what? Probability of getting 1, right? And I can write this as minus y log P1 minus 1 minus y log P0. I can write it like that, right? This is cross entropy only. Even logistic regression, the cost function is cross entropy only. But there are only 2 classes, right? So we wrote it simply. But here there are k number of classes, so it's going to be, the formula is going to be big. Okay. And when you look at this minus log pi, right, p1, you can write this as log log p1 to the power of minus 1, right? It is equal to log 1 by p. That's what I did here. While calculating the probabilities using the cross entropy using the formula, P blue, probability of getting blue, log 1 by P blue, right? This is cross entropy formula only. If you don't put 1 by P blue, right, it's going to be minus for all. Got it? Sesiram, you are asking some question. I think I distracted you. Could you please go ahead? Go again.
It's the same one I was about to ask.
Okay. Yeah, this
Yes,
is
this formula.
This is same formula. Logistic regression and say Softmax regression, cost function is same. There we have only 2 classes. It is simple. Here it is big formula, big, many classes, right? So formula is going to be complex. Okay.
Yes, sir. Can you please go a bit low? Scroll a bit. Yeah, here it is p, right? P log 1 by p.
P log 1 by P only. It's blue, red, green, orange I put.
Yeah, but there is no P in the above formula, right?
Okay. That is like
It's only
why
Y.
we are
Y
taking
log.
Y there actually. So cross entropy formula, original formula is this one. Original probability cross entropy formula is this one. But in our machine learning, right, we actually use yi because I told you, right, for class 1 it is log h of x is the cost function. For class 0, log 1 minus 1 minus h of x is the cost function. To have only one at a given time, we are multiplying that with y. Got it? No?
No.
See, for class 1, records, the cost function is log h of x. Okay. Class 0, the cost function is 1 minus log 1 minus h of x. Log 1 minus h of x. Okay, this is the cost function. So at any given time, you will be calculating cost for one record, right? Do you agree? At any given time, you will be calculating cost for one record and summing that whole cost into total cost, right? Do you agree?
Yeah, please move it.
Huh?
Just
So
yes.
then I have to, right, for a given record I have to calculate cost. So if I cannot sum these two, right? I cannot sum these two. What I did is I am multiplying with y and log h of x minus 1 minus y log h of x because h of 1 minus h of x. If y is equal to 0, what happens? Only this term remains. Okay. Y is equal to 1, this term remains. That way, for the class 1 record, we have appropriate cost function. For class 0 record also, we have appropriate cost function. Even though we combined both, we are able to get, at a given time, only one is working. Either log h of x or log 1 minus h of x. It's a mathematical manipulation, it is, right? Got it?
Yeah, that's actually correct. But the replacement, I did not get it. Instead of
Then
probability, we are replacing with the predicted value.
that is all, theory, and there will be lots of theorems behind it. If we go into that math, right, it will take like even 1 more month to come back.
Okay.
So I think that part, that far is enough. I think if you have
But where
time
we need to consider the predicted value, that is, I mean, y,
here
and
in
where
the
we need
log,
to.
right? In the log,
Mhm.
it's a predicted value. Inside the log, it is a predicted value.
But in the below formula, cross entropy,
Oh,
we
you are
said
saying a predicted class. Predicted class or probability? We are going to use probability, not the class.
predicted value. I said this y is the predicted value, right?
Y is the actual value in the data set. Y is the target variable.
Okay.
Y cap is predicted. Y is target.
Okay. Target value into log of probability.
Right? That is the point here. Y is going to be either 0 or 1. Right?
Mm-hmm.
If you substitute 0, right, only this term will remain. If you substitute 1, only this term will remain. Actual cost function is log h of x. Log 1 minus h of x. We combine these two to get a convex function. And at the same time, right, to accommodate appropriate cost function also.
Yeah.
Okay. Any other questions? We got it, right? The Softmax regression classifier. Simple it is. We are somehow calculating probability, right? Either way, logits are exponential or normalizing it or some way we are actually calculating probability, and we found, the algorithm, the guys who are actually built this algorithm found a way to calculate cost and find out the next theta. That's the key. These formulas and this cost function will help them find out the next theta, so that they'll converge towards the global minimum on all the classes. Okay. So now, how to build a model using
So
Softmax?
here also the function is the convex function, right?
Yeah, it is here also convex function only, but it is complex because there are many classes and all that. So how to build this model is logistic regression only. We'll use logistic regression only. Right? And then the multi-class is going to be multinomial. You need to specify that it is a logistic, it's a softmax regression classifier. But in deep learning, right, there will be other activation functions and other approach. But in machine learning, if you want to do softmax regression classifier, you need to take the logistic regression and then specify multi-class as multinomial. If you use logistic regression, right, it may be using matrix approach, right, the linear algebraic approach. The solver is going to be LBFGS, and here C is a hyperparameter, right, to play with the what you call it as overfitting and underfitting. In our SGD classifier, we had lambda or alpha, right? In scikit-learn, it's called as alpha, to play with overfitting and underfitting. If you give a bigger alpha, will overfitting reduce or increase? If you give a bigger alpha, will overfitting increase or reduce? Regularization, I am asking. If you give bigger alpha, right, or lambda, right, overfitting will reduce because it is already adding lots of weight on the cost function. To reduce the cost, the algorithm will try to reduce theta size. When theta size reduces, right, the equation becomes smoother and it moves towards underfitting. Right? Is my analogy right? Getting it?
So you are saying that it will move from overfitting to underfitting. The direction.
Yes, sir. Yes, sir. If you give bigger lambda, right, how the cost function is now with regularization? MAC plus sigma I is equal to 1 to n, because n number of thetas are there, lambda by m into theta square, right? Do you remember that cost function?
Yes.
You need to remember formulas a little bit. I may have said no need to remember, but if you remember, right, logically you can think and answer. I generally don't remember the concept, like this. I remember formula and try to think and talk. See, if you put a big lambda here, right, there is going to be a lot of weight. Already the lot of weight is there on the cost function. So algorithm will try to reduce the cost by reducing thetas. When it reduces thetas, right, the equation becomes smoother. The equation becomes simpler, right? Instead of having a 10th degree polynomial, it becomes a second degree polynomial because thetas became 0 or maybe close to 0. Right? That way, the algorithm moves towards the underfitting, or it is like model may actually not work well on the train set also. Okay, so if you take lambda a small number, the model will be as initially we would have seen model overfitting. Then we would have started playing with the lambda, right? As we have seen initially, that complex it is going to be and that overfitted it's going to be. If lambda is 0, it is going to be same overfitted model. If lambda is equal to 1, it is going to be the weak model. We moved model towards the bias, high bias or underfitting. Right? So I'm actually recapping the concept because I got a chance here. Right? So like that in C, right? In logistic, in the softmax regression, C is a hyperparameter which actually plays with regularization. Here it is opposite. If you take a bigger C, it's going to be underfitted. If you take a smaller C, it's going to be overfitted. If you take 0 here, model is going to be overfitted. If you take 100, it's going to be underfitted. Okay, opposite to lambda. Okay, in softmax regression classifier, the C value is going to be opposite to lambda. Even in SVM also the same way. Support vector machine we'll see in maybe next week. Right, in SVM also it works the same way. Okay, maximum iterations 1000 I have taken, random state, and fitted. Right, softmax regression predict I predicted, and again F1 score same. Right? Only this part changed. That's it. This one part changed. Rest is all same. Right? And I have got 96% accuracy on train set. I did not look at the test set accuracy, but it will be good, right? 96% means it's good. So softmax regression classifier is working better than SGD classifier. Okay. So SGD classifier, it is giving 90, 92 only because it would have reached close to that global minima, maybe oscillating around it. Right? You know that oscillation problem, right? That's where you are not getting the best accuracy. But when you use deep learning, right, even though you are using SGD or batch gradient descent, there will be many nodes. The algorithm is going to be complex, so it's going to give more accuracy. We'll see on the same data set, you will get 99% accuracy when you do deep learning model on train set and test set both. Okay. So that's about softmax regression classifier.
So here there is no oscillation effect.
There will not be. This is more advanced algorithm. LBFGS and solver, BFGS, LBFGS, and there is one more some FBFGS I think. These are advanced algorithms, and they will converge like normal gradient descent, batch gradient descent.
Okay.
They are all research topics basically. If you want to do more research on LBFGS and want to find a better variant of LBFGS, right? We should be looking into it. But as an engineer, I have to work, right? So I already took like 1.5 to 2 years to learn. And if I go into these, right, I may not have came out of it. So I never went into it. Even Andrew NG says that no need to go, don't go in there. I'll follow. He is my guru in a way. Yeah, so that's it. I think this is enough for today. Is this enough, or shall I take more?
We will continue.
Everybody is okay? Okay, so let us talk about a new algorithm called as K nearest neighbors. This algorithm is useful in doing regression and classification both. We have seen linear regression, which is useful only for regression. Logistic regression only useful for classification, but KNN is useful for regression and classification both. Okay, from now on, right, we cover KNN and then we cover SVM, and then we go back to unsupervised learning, clustering and dimensional regression, and come back to more algorithms, because we know the total process of executing a regression problem or a classification problem now, including error metrics and everything. We know everything about building a model, but now we need to learn algorithms, and we need to know unsupervised learning techniques that may help you, improve performance of the model. Okay, so I'm going to start K nearest neighbors. So I have taken, this is an instance based learning, and this algorithm is not going to be that useful in real time. Okay, I never used this algorithm in any project, but we need to understand it because the mathematical technique behind it is very, very exciting and very interesting. So I'll ask a question, right? Suppose that there is a friend, to you, right? Some X is your friend, and he's a very decent guy, and he works, in a maybe big company, and he is doing some activity and he needs some loan, and his friends are also very nice people, right? So will you are you willing to lend him? A nice guy, are you willing to lend him? That's a question.
Obviously, but it depends on the person who lends.
Yeah, but yeah, as you, right, you will be lending him. Or as I will be lending him because he is a nice guy and his friends are also nice, right? So the way I took that decision by looking at him, moreover looking at the friends around him. Okay, and another person is there. Why? That guy boozes and all gambling and all that he does, and his friends are also like that, right? And I know his friends. I don't know him. But he came to me and asked for a loan. I don't know about that guy at all. Right? He neatly dressed and he came to me and asked for a loan. I inquired, right? Who are all his friends? And I got to know that they're all like boozing guys and all that. And they already defaulted. The other friends already defaulted. Obviously, I am not going to lend this guy, even though I don't know about this person. KNN algorithm works like that. It looks at the neighbors and tries to make a decision. Okay, even though we don't know about this particular person, we look at his neighbors, his or her neighbors, and then try to make a decision. That's how the k nearest neighbors works. Okay, so the algorithm actually takes all the training data and puts into memory. Here, only 10 records are there, where I know the target variable, right? Whether the person defaulted or not, I know. Okay, and when a new person came in for a loan, right, I am trying to look at the closest records. How do I look at the closest records? By calculating the distance between each record and this record. So I take this record, calculate distance from this record, take this record, calculate distance from this record, take this record, like that. From this record to all 10 records I calculate. If you have 1 million records, right, this record to 1 million records, you need to calculate distance. That's one problem with KNN. I'll talk about that later. The training data will be kept in memory, and you calculate distance between the new record and all the other records. Okay, and then you choose a K, right? How many neighbors you want to look into, you decide it. As a data scientist, you decide the count. Okay, and then look into 3 neighbors. So here, if you look at this green dot is this person, 35 years, and salary is 100,000, right? And then I'm looking at the 3 neighbors. So I actually plotted it on a graph so that I can look at the distance. There is another way to mathematically calculate distance also. I'll show that in a moment. But just to clearly visually show you, right? This is not the approach, actually approach. Visually show you, I am showing in a graph. So here 30 years guy, 75,000, that guy defaulted. See this? 30 years guy, 75,000, this guy defaulted. 42 years guy, around 90,000, he did not default. Blue dots are not defaulted, orange are defaulted. And then again another 35 years guy, there is this person. Do I have a 35, 32, 31? I don't know how I got this dot here, but the other person who is actually having salary around 1,35,000 or maybe 40,000, that guy also did not default. So if you look at neighbors, right, 2 did not default out of 3. That means this guy also will not default. I can lend. So that's how the k nearest neighbors algorithm works. So the problem. Sorry.
The record 4.
Record 4. Yes. Record 4 is 35. Yes. Right. So, so that's how the k nearest neighbor algorithm works. I think by now you have understood 2 problems with this algorithm. Can you tell me? What are the problems with this algorithm?
All that loaded into the memory.
Sorry, sir.
And
Sorry.
all the data is loaded into the memory.
Yes, that is one problem.
And you actually don't know about that particular. If you take the example of defaulting,
Hmm.
you don't know about him, but you are deciding based on his request.
Yeah, but that's not a problem basically. That is the technique. But the other problem is, right, if you have 1 million records, you need to keep calculating distance between this record and all 1 million records. Right? If you are predicting for one record, that's okay. You have 1 million records and you are trying to make predictions for 1,000 records. Then it's going to be 1,000 into 1 million number of calculations you have to do. Do you agree? Distance calculation. First record and 1 million records. Find out the closest three. Right? Second record and the 1 million records distance and find out the closest three. Like that, you need to calculate closest three and calculate probability. 2 by 3 is the probability, right? So like that, if its probability is less, you are not going to, you will say no. Probability is more, you say yes. Okay, that is another problem. Distance can, when you are using k nearest neighbors, right? The algorithm will train very fast. When you say fit right, the activity it is going to do is take the train data and put it into memory. When you say predict right, that's when it starts calculating distance like that. Okay, so those are the problems with k nearest neighbors, and on a big data set it's not going to work, and it is like working like a human being, right? And now, right, the problem.
Sir, one more thing.
Sorry.
The another
go ahead.
problem is if the x variables are numbers, yeah, we understand the distance is easily, at least somehow we can find out. But if the param x values, the columns are not numbers and categorical, then again that becomes complex, right? That doesn't give a definition way of what is more, what is less.
Yeah, when they are categorical, right, we'll convert them to numbers. If there is hierarchy in deciding the target variable, right? It is like in America, blacks and whites. I can talk here because no Americans. Right, blacks and whites. There will be discrimination internally. The people, the white people will have discrimination against those black people, and black people will have kind of feeling that these guys are white people and they have racism and all that. So that dilemma is actually deciding whether to lend or not, right? So you can actually give numbers there, different numbers, and then that will be kind of weightage, right? So the label encoding and one-hot encoding again.
If it is hierarchical, yes, that may help. But if it is not hierarchical, it will not help.
Yes, and yes, sir. It becomes a bit complex, but if it is not hierarchical and no impact, we'll remove the column. If we are unknown, then we'll go with the one-hot encoding. And that, one-hot encoding is always like little effect we are trying to capture, right? A little effect in between some categories we are trying to capture, right?
Okay, sir.
Yeah, the technique is same, the approach is same. We'll convert the data into numbers and then apply the algorithm. But in tree-based algorithms, right, they actually take categorical data also, as no need to convert data into numbers. But here it is needed to, we need to convert because it calculates the distance. So when you ask for a prediction for the new record, right, it is calculating distance between this record and all the other records, right? So the distance will be calculated using, I have three formulas. I actually denoted two only. Generally, Euclidean distance is the measure it uses. Okay, Manhattan distance is like it's a squared error kind of root mean squared error kind of formula. This is the record we are trying to predict, right? 35 years and 1 million, sorry, 100,000, sorry, yeah, 1 lakh, and this is the x, right? First record, second record, third record, like that. So if you have to calculate the Euclidean distance, right, you'll use like this: x0 minus p0 square plus x1 square minus p, like that, and apply square root. Or you can take absolute values and calculate. This is called as Euclidean distance. This is called as Manhattan distance. In KNN algorithm, there is a parameter you can specify the distance metric. Okay, so it is going to use this formula and calculate the distances, and then choose the closest 3, and then calculate the probability. Okay, by looking at the y value, it is going to calculate the probability. That's how the k nearest neighbors algorithm works. But there is a problem here. This far you are good, right? I am going to show you one more, detail into the.
What is P, sir? What is P?
In this particular data set, P0 is 35, P1 is 100,000. The new record which we are trying to predict is denoted with P vector.
So P is like yes or no?
No. New record and 35 and 1 lakh is the input, right?
Yeah.
This
so,
is the data and right. We are trying to predict for this record. So we need to calculate distance between this record and this record. This is P0, P1, sorry, P1, P2. This is X1, X2. Again, this is P1, P2. This is X1, X2. P1, P2, X1, X2. P1, P2, X1, X2.
Okay.
Well, let me show you. Here we have it. This is P1, P2. This is X1, X2. Right. We have it. I'll show you. Okay. So see this. I have taken the record which we need to predict. That I denoted with P. And the first record I took. Right. This is P1, P2. This is X1, X2. I substituted into the Euclidean distance formula. Right. P1 minus X1 or X1 minus P1. That doesn't matter because we are squaring it. Right. So and then P2 minus X2. Right. We have got 90,000. Okay. Again, for the second, the same the record and the second record, we are going to make prediction. We are going to calculate the distance. We got 40,000. Right. Again, this record and third record, this record and fourth record. Like that, we'll actually calculate distances between all the records and choose the closest record. Okay. Got it? How the calculation is happening? And I already decided k is equal to 3. I'll explain you how to choose that k maybe tomorrow, right? I'll choose the closest to 3 records and then calculate the probability. This is how the calculation happens. Girigaru, is this clear now? The p and x?
Yes, sir.
Yeah, right? So if you look at this formula, right? If you look at this, yeah, that's fine. So now, right, I found that these 3 are the closest records, out of which one is, defaulted, 2 are not defaulted. So we are predicting that this guy is not going to be default. This guy is not going to be defaulted because he is close to 2 people who are actually not defaulted. Okay, but there is a problem here. There is a problem in the calculation. If you see these calculations, right? Our age is a small number. Okay. And when you substitute that small number into Euclidean distance, we are getting a small number here. Right? And the salary is a big number. And when you substitute into the formula, you are getting a big number. And this big number is dominating this small number. And when you calculate, square root, this is actually minute. That this number is actually minute. Whatever value you have in the age, that is going to be nullified by the salary. Do you agree? While calculating the Euclidean distance, this salary value or the salary's impact is getting nullified. Do you agree?
Yes, sir.
Yes, sir.
Yes.
Okay. To avoid that nullification, you need to bring both columns into same scale. Then the algorithm will work better. See this here? I took the age and took the maximum age and divided. I took the salary, took the maximum salary and divided. Both the data sets, both the columns came into same scale. Now you calculate Euclidean distance, that's going to be more appropriate. Sometimes age may be affecting high than salary. Sometimes salary may be affecting high than age. When you normalize data, in KNN algorithm, when you normalize data, the algorithm works better because of this reason. Right? If one column has got highest value, big values, that value is going to highlight or overtake the decision. Right? By looking at this value, you are making decision. This value, you are making decision whether the record is close or far. Right? But even though the impact of salary is high because of these numbers being high, it is being nullified, and you are not finding appropriate closest records. Right? If there are too many records, then you will see. But theoretically, does it make sense? When input columns are not scaled, bring all columns to similar scale, distance measure will be dominated by features with high values. Okay. In this, salary values are dominated, right? Age, right? So distance calculation, we call it a distance measure between the record we want to predict and the other records. We are calculating distance using Euclidean distance metric. Right? This feature scaling will solve it. Either you do the standard scaling or min-max scaling or divide by maximum, whatever. But you should do scaling and then apply the algorithm. Then the algorithm works better. Okay. So I'll explain how to choose K, and is there any better approaches to do that calculation tomorrow. Okay. Clear? Any questions? Any questions? Good. So I'll stop it here.